Hello everyone, welcome back to the linear algebra series. And today I'm going to be teaching you all matrix multiplication and the transpose of a matrix. So let's first look at matrix multiplication. So when you multiply two matrices, for example A and B, the number of rows in A must be the number of columns in A must be equal to the number of rows in B. So this is something which has to be true in order for us to multiply two matrices. So let me explain what this means. So we have this example here with matrix A and matrix B. Let's look at what matrix A is. You can see that there's two rows, 1 and 2, and 3 columns. So this is a 2 into 3 matrix. Now let's look at matrix B. We can see that there are 3 rows and 2 columns. So this is a 3 into 2 matrix. So we can see the number of columns in A, which is 3, and the number of rows in B, which is also 3. They have to be equal in order for us to be able to multiply these two matrices. So they are equal in this case, so we can multiply them. Now let's look at the second statement. Let's look at what it means. So if A is of the size m times n, so m rows and n column, and B is n times p, then when you multiply A and B, the size of C will be m times p. So let me explain what this means. So let's say this is m times n, and this is n times p. Both of these are n's because they have to be equal, as I explained in the previous statement. So the resulting matrix, when you multiply A and B, will be of the size m times p. So when you multiply matrix A, which is a 2 into 3 matrix, by matrix B, which is a 3 into 2 matrix, the resulting matrix C will be of the form 2 into 2 because it's m times p. M times p. M and p are both 2, so that's why C would be a 2 into 2 matrix. So now let's look at how we can multiply these two matrices. So let me rewrite the matrices. So we have A, which is 1, 4, 2, 5, and then 3, 6. And then B, which is 7, 9, 11, and then 8, 10, and 12. So now let's see. We've already realized that C is going to be a 2 and a 2 matrix. So now I'm going to write the unknowns. So let's call this C11, let's call this C12, or 1, 1, 1, 2, 2, 1, and then 2, 2. So these are the four unknowns, and we have to find these four values. So now let's look at how we can carry out matrix multiplication to find these unknowns. So C11 would be 1 into 7, so 1 times 7. So you multiply the first term in the first row by the first term in the first column. So it will be 1 times 7 plus the second term in the first row times the second term in the first column. So plus 2 times 9. And then finally, the third term in the first row times the third term in the first column. So plus 3 times 11. So this is the value of C11. So you do 1 times 7 plus 2 times 9 plus 3 times 11. And if we expand and solve this out, we would get 58. which is because it's 7 plus 18 plus 33. So now, let's look at how we can find the value of C12. Let's see how we can find C12. So what C12 would be is, it would be 1 times 8. So for C12, it's the first term in the first row times the first term in the second column. So 1 times 8 plus 2 times 10. So you can see the pattern here. So you just continue doing that. And the last one, try to guess it. It is 3 times 12. So that's how easy it is for C12. And if we expand this out, you get 64. So 1 times 8 plus 2 times 10 plus 3 times 12. Finally, let's look at how I'm gonna, let's look at the value of C21. So C21 is this term. Let me choose a different color so that it's easier for you to see. So C21 would be, C21 would be 4 times 7. So 4 times 7. So you can see the pattern here. Since it's this term, C21, you choose the first term in the second row for A. So 4 times 7 plus 5 times 9. So again, you can see the pattern. You're going 1 to the right for the rows and 1 below for the columns, plus 6 times 11. So this would give C21 as 139. And now finally, let's look on how we can find the value of C22. So C22 would be 4 times 8. So we'd go this times this, 4 times 8 plus 5 times 10 plus 6 times 12. And that would give C22 to be 154. So that is C22. So now let's write out our values. So C would be, our first term right here is C11, and our value of C11 is 58. So we'd write 58 here. C12 is 64. C21 is 139, and then C22 is 154. So that is our resulting matrix when we multiply matrix A with matrix B. And we can clearly see that this matrix is a 2 into 2 matrix. So this satisfies our previous example where we said that if we multiply a 2 into 3 matrix with a 3 into 2 matrix, the resulting matrix would be a 2 into 2 matrix because we're using M and P. So the resulting matrix is a 2 into 2 matrix. So that's how easy it is. Now let's go and look at how we can find the transpose of a matrix. So for the transpose of a matrix, this is a really, really simple topic. So let's say we have matrix A, which is 1, 4, 2, 5, and then 3, 6. And they ask you to find the transpose you write it as a T on top of the A. That would simply be 1, 2, 3, and then 4, 5, 6. So what we did was we swapped the rows and columns of A. So if A is a M into N matrix, then AT, or the transpose of A, would be an N into M matrix. So you can see that this row became the first row, became the first column in this transpose. We can see that it became the first column. And then the second row became the second column. So that's how easy it is. Okay, so that's it for today's video, guys. In today's video, I discussed the really important topics of matrix multiplication and the transpose of a matrix. So this might seem like something which is really easy, but you'd rarely get a question in a test where they only ask on how you find a matrix multiplication or a transpose. You'll usually have to use these techniques to find other solutions, like in system of equations, etc. So I hope I was able to make these two topics clear, and please consider liking and subscribing. Thank you so much.